Hello, everybody. This is Schlansky's not as common guide to 65. I want to be very clear. You're going to see the majority of these questions. It's just not every single Regents asks these like the Schlansky's guide to 65. But you're going to see the majority of these. They're not hard, so let's get right to it. Exterior angle theorem. When you have an exterior angle in a triangle, the rule is that the interior angles, this one plus this one, add to equal the exterior angle. So the two interior angles, 4x minus 5 plus x plus 40, add to equal the exterior angle, 6x plus 20. That's how you set it up. Interior plus interior equals exterior. From here, you can solve the equation. You can use the equation solver. Let's jump right to that in case you're just watching this video right now. For the equation solver, if you can't do algebra, that's okay. We math up, enter. E1 is the left-hand side, 4x minus 5 plus x plus 40. The right-hand side, 6x plus 20. Graph 10, graph, make sure you hit graph that second time, x equals 15. Or, of course, we can do the algebra. If you can do the algebra, combine like terms, 5x plus 35 equals 6x plus 20 minus 5x minus 5x. 35 equals x plus 20 minus 20 minus 20. X is 15. Make sure you answer the question. It could ask for X. In this case, it asks for angle QPT. Well, angle QPT is 6X plus 20. So I do 6 times 15 plus 20. That's 110. So again, for an exterior angle, if you have an angle outside the triangle, interior plus interior equals exterior. Intersecting medians. Whenever you have medians intersecting, they form what's called a centroid. The answer is they are cut in a ratio of 2:1. So whenever we see intersecting medians, we do 2x plus 1x equals whatever the median is. So here it says that yn is 30. So it's 2x plus 1x equals 30. 2x plus 1x is 3x. I solve it. X is 10. So the two pieces of the median are 2x and 1x. So it's 2 times 10 and 1 times 10. 2 times 10 is 20. 1 times 10 is 10. So again, I'm looking at this purple piece. So the small piece of it is 10. That's ys. And the big piece of it is 20. That's Sn. So ys is 10 and Sn is 20. They're not going to ask you for both, but they could ask you for the small piece, or they could ask you for the big piece. So again, whenever you have intersecting medians, and this is one of your key pictures, this is on Schlansky.com. There's not that many key pictures here, but whenever you see this picture, you need to know to do 2x plus 1x equals the median. And again, once you get your answer, substitute into 2x and 1x. The smaller piece is 1x, the bigger piece is 2x. Performing dilations. Now, you could be dilating a shape, you could be dilating a line segment. Either way, it wants me to dilate by a scale factor of 2 centered at point D. So, from the center, think of the center of dilation as an explosion. Things explode, things go away from the explosion. So I'm counting from the center of dilation. I'm counting away from the center of dilation. So I'll start with point B. How do I get from the center to point B? I go left 1, up 3. Do that the scale factor number of times, in this case twice. This counts as 1. Left 1, up 3 counts as 1. Left 1, up 3 counts as 2. That's B prime. If it was a scale factor of 3, I would go left 1, up 3 a third time, but it's not. I repeat the process for C. From the center, I count to C. So from D, I'm going 1, 2, 3 left, 1, 2, 3 down. That counts as 1. 1, 2, 3 right, 1, 2, 3 down. That's C prime. And now for A, down 1, left 3. That's 1, down 1, left 3. That's 2. I take a straight edge, which I'm not going to do right now. I connect them. That's it. If it asks you to state the coordinates, and that's it. For dilations, count from the center of dilation to each point, and do that the scale factor number of times. And the first one counts as 1. Just to show you quick while I'm here, if it's a line segment, it's the same thing. If I'm dilating this by a scale factor of 2, from the center, I count to each point. B is down 1, right 1. Do that twice. C is down 3, left 1. Do that twice. And you'd answer the question from there. So whether it's a line segment or a shape, whenever I'm dilating points, I count from the center of dilation. I go to each point. I do it the scale factor number of times. Identifying vertical stretches, horizontal stretches, and dilations. So basically, if it's being pulled horizontally, it's a horizontal stretch. If it's being pulled vertically, up and down, it's a vertical stretch. If it's being pulled in both directions, then it's a dilation. Dilation goes in both directions. So it says that A prime is -7, 6. It says that B prime is -5, 10. It says that C prime is -2, 10. And it says that D prime is -2, 6. So some of you can see it pretty clearly. What's happening to it? It's being pulled vertically. Therefore, it's a vertical stretch. If you can't see it clearly, just pick any point in its image. Let's say A to A prime. What direction did it move? It moved up. If it moved up, it's vertical. If it moved side to side, then it's horizontal. If it moved in 2 directions, then it would be a dilation. So that's what a vertical stretch would look like. And just so you can see it, what a horizontal stretch would look like if D moved there and A moved out here somewhere and C moved there and B moved there. That black, that would be an example of a horizontal stretch because it was being moved horizontally. So if it gets pulled vertically, it's a vertical stretch. If it gets pulled horizontally, it's a horizontal stretch. And if it got pulled in both directions, that would be a dilation. Performing a vertical and horizontal stretch. Well, it's all about this right here. If it says that xy becomes 2x comma y, we're just going to apply that rule. So my points are -2, 3, 3, 6, 2, 1, and I want to apply the rule 2x comma y. Just do what it says. This is saying multiply the x by 2. So multiply the x by 2, multiply the x by 2, multiply the x by 2. It's saying don't do anything to the y. So don't do anything to the y, don't do anything to the y, don't do anything to the y. I plot that point. This grid is a little bit hard to see. So I have -1, 2, 3, 4, 3. I've got 6, 6. I've got 4, 1. And based on what we just did in the previous example, hopefully we can see that this is a horizontal stretch because it's being pulled horizontally. If I take a look at any point in its image, it moved right. It moved right. It moved left. It's being moved horizontally. Therefore, it's a horizontal stretch. This problem is saying it's a horizontal stretch, but the previous question had you identify it. You need to go both directions. If it gives you a rule, you just apply the rule. In this case, multiply the x by 2, keep the y the same. Here, it says keep the x the same, multiply the y by 2. So I keep the x the same, I'd multiply the y by 2. Whatever it says to do, you do. Rigid motion properties. This is a really easy question, probably the easiest you can get. They all produce a congruent figure except for dilation. So if it ever says which is not congruent, the answer is going to be dilation. Now, again, that vertical and horizontal stretch, that's new to the curriculum. That would be an answer as well. Vertical stretch and horizontal stretch also do not produce a congruent figure, but that's not what has been asked. If it says which one is not congruent, it's dilation. That's it. When I dilate something, the size changes. It's not congruent to the original. So whenever it wants to know which one's not congruent, dilation. That being said, horizontal stretch and vertical stretch also are not congruent. Number 19. It wants you to determine if the triangles are congruent after a rigid motion, and it wants you to explain why. Well, as long as it's a reflection, a rotation, or a translation, the answer is always yes. Is triangle ABC congruent to triangle ABC prime? Yes. A blank is a rigid motion. A translation in this case is a rigid motion. And then we have our song. A rigid motion preserves size and angle measure, producing a congruent figure. That's what you write for your explanation. A rigid motion preserves size and angle measure, producing a congruent figure. That's always the explanation. If it says, use properties of rigid motions to explain why they're congruent, or if it just says explain why they're congruent, the answer is always yes. A blank is a rigid motion. In this case, a translation is a rigid motion. A rigid motion preserves size and angle measure, producing a congruent figure. Which brings us to bow tie problems. Listen, this could be in the guide to 65. I can't tell you exactly how often it's going to come up, but it comes up, and it's not hard if you know how to do it. It's on your key picture sheet. I like to use colors for this. Basically, whatever's on the same diagonal corresponds. These correspond because they're on the same diagonal. These correspond, and the parallel sides correspond. The reason is because of the alternate interior angles. That's why that's the case. You don't need to know that. You just need to know that the sides on the same diagonal correspond. So LS and SO are going to correspond. PS and SA are going to correspond. And LP and AO are going to correspond. Make sure you put an X on what you're trying to find. LS is 8, SO is 12, AO is 11, PS is 6, it wants SA. Another thing to be careful of, triangle 1, triangle 2. If I call this triangle 1 and this triangle 2, if triangle 1 goes on top for one of them, triangle 1 must go on top for both of them. So I'm going to go orange. My orange, 6 goes over X. And since 6 is in triangle 1, the 8 must go on top. 8 goes over 12. In this case, I don't have anything that corresponds to the 11, so I'm not using it. And then from there, I cross multiply and solve. 8 times x is 8x. 6 times 12 is 72. And I finish it off, and x equals 9. For bow tie problems, the corresponding sides are on the same diagonal. Those two correspond. Those two correspond. These correspond. And again, if this is triangle 1 and this is triangle 2, if triangle 1's on top for this one, triangle 1 must also be on top for that one. Determining if a proportion is correct. They try and trick you with these ugly, annoying pictures. Cross it out, draw your own pictures. It's giving you the letters right there. So I draw my own two triangles. We did something like this in the guide to 65. I label the letters the way they're given in the problem. So if I go AEC as left top right, then BED must also be left top right. Now I look at the letters. I look at the letters horizontally and vertically. One direction should correspond. One direction should be in the same triangle. It doesn't matter which direction's which. So I have the notes here. One direction the letter should correspond. The second they should be in the same triangle. It doesn't matter which direction's which. So CEEB. CEEB. They're not in the same triangle. They don't correspond. This is the right side. This is the left side. So that's not correct. Choice 2. AEAC. AEAC. They're in the same triangle. That's good. AEBE. AEBE. They correspond. That's good. One direction's in the same triangle. One direction corresponds. That's a correct proportion. Let's look at the rest of the choices. ECBE. ECBE. They don't correspond. They're not in the same triangle. And finally, EDAC. EDAC. They don't correspond. They're not in the same triangle. Which proportion is true? Choice 2. Draw your own pictures. Label them the way that the letters are labeled in the problem. Look horizontally, look vertically. One direction should correspond. One should be in the same triangle. It doesn't matter which direction's which. Center of dilation and scale factor. The main priority here is scale factor. Since we're talking about it, we might as well throw center of dilation in here, but the more priority here is scale factor. Got a song for it. Image over original. A scale factor. Scale factor is image over original. It says that DEF is the image, so this one's the image, this one's the original. So I need any pair of corresponding sides, and I put the image over the original. So if I'm on the grid, I'm going to count. It doesn't have to be on the grid. It could be, there's many different ways I can get this question, but I'm going to count a straight side, because if I did a slope side, I have to use distance formula. Who's got time for that? DE is 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. AB is 9. So scale factor is image over original. Image is 3. Original is 9. 3 over 9. You can go to your calculator if you need to. 3 over 9 is 1/3. Scale factor is image over original. Now, center of dilation. I don't want to erase. Let's keep that there. So for center of dilation, it's going to be hard to do this without a straight edge, and I don't think I have a straight edge here. So I'm going to connect any point to its image, and I'm going to extend a line. So I'm going to do this freehand, which is not a great idea, but it is what it is. So I'm going to connect B to E. Then I'm going to connect any other point to its image. So I'll do C to F, and I'm going to extend it. Where those lines intersect, that's your center of dilation. So again, I'm a little freehand here. It's not perfect, but looks like it's going to be 2, -3. Generally, it will be multiple choice where you'll see the choice. You'll see one that's closer to that area. My main priority is not center of dilation, but since we're talking about scale factor, it's right there. Might as well take the 30 seconds to talk about it. To find the center of dilation, connect any point to its image. Do the same thing for a second point its image. Extend those lines where they meet. That's your center of dilation. Density. Density, DMV. Population density is PD pi. Well, listen, there's been 3 exams of the new next gen so far. 2 of them had population density. 1 of them had density. Before that, they were both rarely asked. Population density made the guide to 65. Density made the not as common guide to 65. Density is mass over volume. So I'm going to start by calculating volume. Again, you need to know your volume formulas. We talked about building this last in the guide to 65 video. You need your volume formulas. So we build those. Volume of a rectangular prism is this particular one. So I write down the formula for the volume of a rectangular prism. Length times width times height. 4 times 3 times 8. 4 times, oops. Did this thing freeze on me? 4 times 3 times 8 is 96 cubic centimeters. So density, DMV. Density is mass over volume. The mass it will give you, they're not going to give you some scale to start weighing things when you're taking your test. They'll give you the mass. Volume is 96 cubic centimeters. Divide them. 1824 divided by 96 is 19. So the density is 19 grams per cubic centimeter. We talked a lot about volume in our Schlansky's Guide to 65. We'll talk about it more in our Schlansky's Guide to 85. You have to be able to find your volume by building your volume formulas. And then from there, you use the appropriate formula, you find your volume. For density, it's mass over volume. So once you have your volume, you just put the mass over it and divide. Again, these are not difficult. They're just not as commonly asked. Maybe these range from coming up from like 25% of the time to 50% of the time, where the guide to 65 comes up maybe like 60 to 90% of the time. But a bunch of these you're going to see, depending on which exam you take. I can't say which ones, but they're not hard. It's just a matter of knowing how to do them. This picture is on your key picture sheet as well. You just need to know these pictures. If you know these pictures, it's simple. When you see that picture, a quadrilateral inscribed in a circle, the opposite angles add to 180. So I've got SBR. Let's get a more fun color going on here. SBR is 40. I've got BRE is 91. Well, the rule is when I have a quadrilateral inscribed in a circle, the opposite angles add to 180. So 180 minus 91 is 89. This angle is 89. For the pink, this is opposite that. 180 minus 40 is 140. That's it. BSC is 89. SER is 140. That's it. When I have a quadrilateral inscribed in a circle, the opposite angles add to 180. So the pinks add to 180 and the blacks add to 180. Perimeter of a rhombus. Again, it's not hard. It's just you have to know how to do it. There are some properties of the rhombus, which we'll see in our Schlansky's Guide to 85. But for this, it's just about knowing the process. Diagonals bisect each other and are perpendicular to each other, so there are right triangles formed. Since diagonals bisect each other, if PR is 16, this is 8 and 8, and if QS is 30, this is 15 and 15. I want to find a side of the triangle, so within this shape, I have a right triangle. I have 2 sides. I want to find the third, so I do Pythagorean theorem. A and B are the legs, 15 and 8. So it's 15 squared plus 8 squared equals C squared. Use the calculator if you need to. 15 squared is 225. 8 squared is 64. 225 plus 64 is 289. Square root. We can use the calculator if we need to. Radical 289, second radical, 289 is 17. And yes, you can use the equation solver for this. So now that I have that this is 17, because a rhombus has all sides the same, they're all 17. So for the perimeter, I'm doing 17 times 4. Use the calculator if you need to. The perimeter is 68. For perimeter of a rhombus, cut the diagonals in half. 30 becomes 15 and 15. 16 becomes 8 and 8. They're perpendicular, so there's a right angle and there's a right triangle. Use Pythagorean theorem to find a side. Once I have that side, multiply it by 4 since all the sides are the same. That's it. So, much shorter than the guide to 65. It's very predictable. Most of the exams are very predictable. You're going to see these questions. You're not going to see every single one, but depending if you take it in June or August and January, you're going to see a bunch of them. So be prepared for them. Exterior angle, the angles of the interior angles add to equal the exterior angle. When you have intersecting medians, 2x plus 1x equals the median. The small piece is 1x, the big piece is 2x. To dilate a shape or a point, I count from the center of dilation to each point. I do that the scale factor number of times. And the first one counts as 1, whether it's a segment or a triangle. If it's being pulled horizontally, it's a horizontal stretch. So the black on the screen right now is a horizontal stretch. The pink is a vertical stretch. And if you don't see it, just take a look at any point in its image. If it's going vertically, it's a vertical stretch. If it's going horizontally, it's a horizontal stretch. If it's going both, it's a dilation. To perform a vertical or horizontal stretch, just follow whatever the rule is. If it says to multiply the x's by 2, then multiply the x's by 2. If it says to keep the y the same, keep the y the same. They all produce a congruent figure. They're all rigid motions except for a dilation. So whenever it says which one's not congruent, the answer's got to be dilation. And yes, it could be a vertical stretch or horizontal stretch as well. They've never asked that. They could. Dilation's not congruent. Horizontal and vertical stretch are not congruent. If it says to explain why they're congruent, a blank is a rigid motion. A rigid motion preserves size and angle measure, producing congruent figure. Bow tie problems, the corresponding sides are on the same diagonal. So those correspond, and those correspond, and the parallel sides correspond. And make sure triangle 1, triangle 2. If this triangle goes on top for one of them, it must go on top for both of them. To determine if a proportion is correct, draw your own triangles. Look horizontally, look vertically. One direction should correspond. One direction should be in the same triangle if it's going to be a correct proportion. Image over original. A scale factor. Scale factor is image over original. Count the sides if it's on the grid, and it will have to tell you which one the image is. And then while we were talking about it, to find the center of dilation, connect any point to its image, extend the line, do the same thing for another point its image. Where they meet, that's your center of dilation, and use a straight edge. I just don't have access to a straight edge right now. Density, DMV. Density is mass over volume, so we calculate our volume using any of our volume formulas, which again, you're going to have to build, and then just put the mass over it and divide. Quadrilateral inscribed within a circle, the opposite angles add to 180. And perimeter of a rhombus, cut the diagonals in half, use Pythagorean theorem to find one of the sides, multiply that by 4 to find the perimeter of the rhombus. That's it. Again, I would say like and subscribe. I really don't care. Don't like, don't subscribe. I really don't care. Kick butt on your geometry test so you never have to watch a geometry video ever again. That's what I want. Make it happen. Goodbye.